tends to this next video, we are looking at in this one the point gradient form of a line. So what I mean by that is this is where you're given a point that your line passes through, and you're either given the gradient or you're given enough information to find the gradient, and you're asked to find the equation of that line. So you might come across a couple of cases. You might come across when the gradient and one coordinate are given to you. So I'll show you some examples of that. Or the other thing that you can use the point gradient form of a line for is when you're just given two coordinates only. So that's what I mean by you're given enough information to get the gradient, because of course all we need is two coordinates and we'll be able to find the gradient of that interval. So the point gradient form of a line looks like this. We've got y minus y1 equals m multiplied by x minus x1. Now, this y1 and x1 here, these ones, these are the ones that are going to be given to you, this x and y coordinate will be given to you in some form. So generally in the question they'll say, look, the line passes through this particular point. That's your x1 and your y1 points. The other x and y, they're our variables, so they're actually an unknown value, I guess. They could represent any x and y coordinate, which is why we're actually going to leave them in their variable form, because you'll know that from working with equations, especially when we're working with something in the form y equals mx plus b, to write our equation, all we need is this m value and b value. So you're going to have the variables of y and x in your equation. So that's what these are here, the y, the x and the y here. M, of course, is our gradient, which we know already. Now, where does this come from? Well, it comes from our gradient form, our gradient rule that we've talked about already. So the gradient is y2 minus y1 over x2 minus x1. Now, if I just take away for you this as y2, we just leave that as a variable y. Same with x2, we leave that as variable x. You might be able to see where this rule actually comes from, because if I multiplied both sides by this denominator of x minus x1, of course when I do that to this side it's going to cancel out, so you'll see that I'm left with this y minus y1 equals m x minus x1, and this is the point gradient form of a line. So that's where it comes from, and I want to show you what use we have for this particular form of a straight line equation. If I take you to an example, here we go. I've got find the equation of a line that is parallel to the line with this equation and passes through these particular points. So I mentioned that sometimes you're given the gradient, sometimes you're given enough information to find it. And this is a case where we're given enough information. If a line is parallel to this line, so the line that we're looking for is parallel to this, it means it must have exactly the same gradient. So if we look at the gradient of this line, you'll see that it's -2. So that means that our gradient value for our line must be also -2. So I'm going to write that for both, because it doesn't matter what point it passes through. What we do know is it's parallel to this one, so we know its gradient. The next thing we want to do is establish what the rule of the line is, now knowing its gradient and what point it passes through. So what I'm going to do is I'm going to label these points as x1, y1. So the given point, same with this one over here. And then I'm going to use this gradient point form, or point gradient form, to establish what the rule for this particular line must be. So, first of all, I'm going to substitute all of my information into the rule, like so. To finish off, I want to try and get this in my slope-intercept form. So I want it in the form y equals mx plus b, just like this one is up here. So I might just do that in 2 steps just to show you. You can do it in one, however. So -2x plus 2, as it's -2 by -1. And then, of course, I'll add 10 to both sides. So 2 plus the 10. There's my rule. Y equals negative 2x plus 12. I'll do it now with a different point, but same process. We've got the gradient and we've got that point. So this one's going to be y minus 0 is negative 2x minus negative 1. So do be careful here with your negatives, as I've got a negative, a minus negative here. So of course that means, well, the y minus 0 just cancels out to y equals. This is going to be negative 2x. Now, of course, this bit here would be x plus 1. So it's going to be negative 2 by positive 1. There we go. All right, so what we should have are two lines, of course, that have the same gradient, negative 2. It has to be the same as the gradient up here. What we can do is we can plot that and have a look whether they are parallel. And of course, we can do that by finding the x and y intercepts and then plotting. So we can see that they've got different y-intercept, but they do have the same gradient. So one's just going to be a bit below the other one. I'm going to show you on the calculator how we do that. All right. What I want you to do is go down to the bottom here where you've got add graphs to a new document. So we're going to add a graph, and you'll see you'll get your x and y axis. And you'll see up the top here that we've got f1 in brackets x equals. This means the function of x equals. So the equivalent to this is y equals. It's basically giving us that bit already. So we're not going to actually type in y equals. We're going to imagine that the function of x represents the y. We're going to type in our first one, which was negative 2x plus 12. And you'll see that the line comes up here. Now, the problem is at the moment I can't see the y-intercept. I know it's occurring at y equals 12. So what I'm going to do is change the settings. So menu, we go down to window or zoom. And I'm just going to go to the first one there, which is window settings, because that's going to allow me to change the numbers. So y minimum just means where does your y-axis start. I'm going to put it, say, negative 10. And y maximum, I'm going to go up to 20 because I know that the intercept's at 12. So if I do that, as you can see now, I can actually see the entire line. All right, now I want to add another line. So the easiest way to do that is to press on tab. And you'll see that what comes up is F2. So you see the first one was called F1, second one F2, and if I add a third line, of course, it'll be called F3, etc. So we ignore the f of x, that's just telling me the y variable. So I'm going to type in the next part, which is negative 2x minus 2. And there's my second line. Now, as you can see, they are parallel lines, just as we'd expect, as they've got the same gradient. Now we can have a look at the line by using the trace function, so we can have a look at the different points that this line passes through. So press on menu again and go down to number 5, which is trace. So this one here, and you'll see the top one, graph trace. You'll see that you get this little cross come up, and what you can do is you can scroll across. That's down in the corner, it's telling me what coordinate it's on. It's at 0, 12. But I can scroll down and I can also see the x intercept, which as you can see is 6, 0. If you want to go to the other line, you can just press the down arrow and it will jump to the red line. And I can move across this line as well, and I can see the y-intercept, and I can also see the x-intercept, which is occurring at x is negative 1. So what we can do is we can actually check our values and check that they do pass through the lines, the coordinates that we were given. That first line, the negative 2 x plus 12, we were told that it passed through the point 1, 10, so x value of 1. So what I want you to do is just press on 1 on your keypad, and you'll see it pops up with x equals 1, and press enter. Have a look down here. We can see that the line passes through that point 1, 10. So it's basically confirmed that particular line for us. Press the down arrow to get to the red line, the second one, and the coordinate we were given there was negative 1, 0. Now we were on that point before, so there it is there. Negative 1, 0 was the x-intercept, so we know that it passes through that point. So I guess it's a way of checking our answers as well. By plotting them, you can check that they do in fact pass through those points, or of course, you can substitute your x and y coordinate into your final equation that you get, and do check that the equation is true. So check that the left-hand side equals the right-hand side. I'm going to show you a different one now. And that's this one here. So it's getting a little bit more challenging. Only because, again, we're not told the gradient all of the time, but we're told some information that will help us get the gradient. And in this one, we're finding a line that's perpendicular to this one here. Now this one has got a gradient of 2 over 3. So what I can say is that the gradient of, just use a little bit of notation that we haven't really used before, the gradient of the perpendicular line is 2 over 3. Now there's a couple of ways you can generate the line that we want. The line that we want will have a negative reciprocal gradient to that one there. So it's going to be negative 3 over 2. That's one way to do it. So remember, we flip the numerator and denominator and we make it negative, or we switch the positive to a negative, negative to a positive. The other way that you can do it, of course, is recognize that m, the gradient you want by the one that's perpendicular, will be equal to negative 1. Therefore, m by 2 over 3 will be equal to negative 1. So m must be equal to negative 1 divided by 2 over 3. So that's negative 1 times 3 over 2. That's the keep, change, flip. So that's negative 3 over 2. So as you can see, there are a couple of ways. Now that's not really easy to see. I think I've cut it off there. There are a couple of ways to get your gradient. I might just flip that over there, just so you can clearly see how I got that one. There we go. So 2 different ways to find your gradient there. Whatever's easiest for you, I guess, is fine by me for you to use. All right. So we've got the gradient now. The gradient is negative 3 over 2. But of course, now that we've got the gradient, so our information, and we know that it passes through this point, P16. There we go. So what I'm going to do is I'm going to use that, that same equation that I used before, the point gradient form of the equation of a straight line. I might actually bring up a new page for this because I have run out of space. And I'll just copy across the information I had as well. So I had m equals negative 3 over 2, and the point itself was 1/6. All right, so let's do this. We've got our point gradient form, which looks like this. And of course, now we want to substitute. So here is our x1, y1. So it's going to be y minus 6. The gradient is negative 3 over 2. And that's by x minus 1. Okay, so y minus 6, I'm going to expand first. So that's going to be negative 3x over 2. And that's going to be plus 3 over 2, as it's a negative times by a negative. All right, finally, we will add the 6 to both sides, and then I might just clean it up by getting the same denominator. So I'm talking about this bit here. I've got 3 over 2, which is obviously 1.5, plus 6, so that's going to be 7.5. So that's going to be 15 over 2, but the other way to look at it is 6 is 12 over 2. So multiply top and bottom. Remember, this is over 1. Top and bottom by 2. And then add it together. So I might just move this over a little bit. Again, I am very guilty of running out of space. So move it right over. divide this up a bit. And I'm left with, of course, y equals negative 3x over 2 plus 15 over 2, or 7.5. And that is my equation. Now, of course, what I can do to check is I can substitute this value into my rule. So substitute the y value is 6, the x value is 1, and I can check that that actually works, and it should. If I've got y is 6, this would be then, and x is 1, that'd be negative 3 over 2 plus the 15 over 2, so that's going to be 12 over 2, which is 6, so it does work. Okay, I will show you one more before I finish up this video. Now, of course, what you can do is you can use your calculator to plot these. You can plot these two graphs like I did before, and you can check that they're perpendicular. Of course, you're not going to be able to see the actual angle is perpendicular, or it is 90 degrees, but you can sort of see the line at least. I'm just undoing what I did before to get rid of these ones, and then I'll press tab to add a new graph. So my two lines were 2 over 3x minus 3. So there's one line. Press tab, get your second one, and it was negative 3 over 2x plus 15 over 2. And there's my other line. So you'll see that they are perpendicular. And if I go onto the red one, I'll go to 5, trace, graph trace. The red one, which is the one I found, should pass through the point 1, 6. I'll put x is 1, and there we have 1, 6. So it does pass through that point as expected. All right, last example now. This is where you have 2 points. So you're not given the gradient. You've got 2 points, however, that will allow you to find that gradient. So we do our gradient formula as usual. M equals y2 minus y1, x2 minus x1. Doesn't matter which you pick as your x1, y1, x2, y2. It doesn't matter. So I've got 7 minus 6. That's the difference in the y values. Then I've got negative 3 minus 2. So that's going to be 7 minus 6 is 1. Negative 3 minus 2 is negative 5. So there's my gradient. I then have, of course, the point gradient form of a straight line, which looks like this. And at this point, you've got two coordinates to choose from. I'm just going to use this as my x1, y1. Doesn't matter which ones you choose. I could do it with this one over here, and I will still get the same line. I'll still get the same equation. So let's move back to white. Y minus 6 equals my gradient, which was negative 1 over 5, x minus, and I've got x value of 2. All right, so y minus 6. Now I'm going to multiply this out. I'm going to get negative x over 5. That's the same as negative 1 over 5x. This is a negative by a negative, so that's going to be plus 2 over 5. And now, of course, I add my 6 to both sides. So I'll do what I did before. Got my plus 2 over 5 plus 6. And we want to get that as the same denominator, the 2 over 5 and the 6. So remember that's 6 over 1. And we want the same top and bottom, we want the same denominator, so we're going to multiply top and bottom by 5. So negative x on 5 plus 2 on 5 plus 30 on 5. So your final answer is going to be y equals negative x on 5 plus 32 on 5. And again, I've run out of space. I really need a larger screen. So I might just put a line down here to write my final answer. Negative 5 plus 32 on 5. That could, of course, be written as negative x plus 32 all over 5 as well. That would be okay. All right, so I will leave it there. There's nothing else that I'll need to show you in this particular video. So just some key things, of course, to remember that there is a summary, of course, if you'd like to jot it down. When you are finding the equation of a straight line, you want to use this point gradient form. X1, Y1 is your given point, so we substitute that in and we make sure we find the gradient. It may be that it's parallel to another line, it might be perpendicular to another line, or if 2 points are given, you're going to have to find that gradient first before you use this particular rule. All right, I will see you in class so that we can have a practice of these.